All right, good evening, everyone. Today I'm going to talk about dividing polynomials. All right. The first thing we want to take a look at is how many different ways I can divide polynomials. There are three techniques that we're going to have. The first one is called monomial division. The second one is long division. And the last one is something called synthetic division. All right, let's start with the monomial division. All right, that one, this is pretty basic. Take a look at the example I have. It says divide 8x to the fifth plus 3x to the fourth minus 6x squared plus 4x. Divide all of this by 6x squared. Well, to do this, I'm going to create a whole bunch of different fractions. Because I've only got this single term of 6x squared on the bottom, I can divide each individual term on the top by the 6x squared like this, and then just simplify each fraction that simplifies. Let's see, for 8 and 6, I know that that simplifies into 4 over 3. And since I have 5 x's on the top of the fraction and 2 x's in the bottom, when I divide, the 2 x's in the bottom will cancel with 2 of the x's on top, but I'd still have 3 x's left on the top. For the second term, in this fraction, the 3 and the 6 simplifies to 1 over 2. And with the x's, I have 4 x's on the top over 2 x's in the bottom. I would still have 2 x's left on top. Now, of course, we know that because we have 1x squared, that just simplifies into just plain old x squared. So we'll just make that into x squared over 2. The third fraction, well, that's just 6x squared divided by 6x squared, and we know that anytime we divide a number by itself, we just get 1. And then lastly, plus 4 over 6 reduces to 2/3. I've got 1x on the top. I've got 2 x's on the bottom. Well, if I canceled, I would still have an extra x left on the bottom. So when I divide this original problem right here by 6x squared, I end up getting this as my full answer. And that's how we do monomial division. Not bad, just, again, divide each term by the single term on the bottom. Now, again, this is reliant. The only time you can do this, you can only have a single term here. All right, the next idea we're going to look at is long division. For long division of polynomials, we actually want to take a look at long division of plain numbers and just recall how we do long division there. All right, to do long division, 891 divided by 42. Remember that when you draw your division for long division, the first number goes inside the division box and the 42 goes on the outside. Now this is how I do this. I focus on the first number outside the division box and the first number inside the division box. And I ask myself, what do I need to multiply this first number on the outside by to get this first number on the inside? Well, the answer to that would be a 2. So I say, well, put 2 over the 9 and multiply it. I go 2 times 2 is 4. 2 times 4 is 8. I get 2 times 42 being 84. I get my answer. I subtract. I get 5. The 8's cancel. And I'm done with that first part. Now I bring the next number down and I start the process all over again. Again, this time it's what do I need to multiply my 4 by outside the box to get the 5 inside the box. Well, in this case, I would just need to multiply by a 1. So I put a 1 up here and I multiply this. 1 times 2 is 2. 1 times 4 is 4. Once I've multiplied, I subtract, and I get, well, I need to borrow 1 here to get 10, and it becomes a 4, and 10 minus 2 is, where are we at? I'm wrong, that's 11, my bad. 11 minus 2 is 9. So I get 9. But since I'm out of numbers to divide inside the box, this 9 is called my remainder. Okay? Now, as you recall, there's two ways to deal with the remainder. I can either put R9, or I could actually make this into a mixed number and say that's 21 and 9 over whatever number was on the outside again, 42. So 891 divided by 42 equals 21 and 9/42. Now that's how we do long division with plain numbers. We've been doing this for a long time. Again, the key though is you have to think about what's on the what you need to multiply the first guy on the outside by to get the first number on the inside. Come up with that answer and then multiply that answer times everything on the outside. Put your answer underneath the box and then subtract, bring down the next number, and start the process over again. All right, now I'm going to show you how to do this with polynomials. The process, or the algorithm, is the same, but just with variables. Let's take a look at an example. Suppose I said divide using polynomial long division. I've got x squared plus 2x plus 6 divided by x minus 3. Well, similar, I'm going to take the first guy and put him inside the box, and the second guy outside the box. And now, to divide, I say to myself, what do I need to multiply this first guy by outside the box to get to this first guy inside the box? Well, x times what is equal to x squared? Well, an x. So I need to multiply this outside by an x. So now notice, and this is the way I do this, I put the x over the x's in this x column right here. These line up right here. Okay? Now, hey Lucy, when I multiply, I'm going to multiply the x times the x and the x times the negative 3. Just like I multiplied that 2 times the 4 and times the 2. When I multiply that, I get x squared minus 3x. Now, when I multiplied the 2 over here and I got 84, what did I do next? I subtracted. I said 9 minus 4 is 5 and 8 minus 8 is 0, right? Well, here I need to subtract. So I'm going to subtract this whole thing. So when I do this, I get x squared minus x squared is 0, and 2x minus a negative 3x is actually plus 3x, so plus 5x. Okay? So ultimately, would you agree that when I subtract this bottom, I actually just could change the sign of this bottom and then add? So here's how I talk about this. Let me go back to where I was at before. After I multiply x times x and get x squared, and x times negative 3 and get negative 3x, to subtract, we will, as I say, draw the line and change my signs. I changed the signs of those two bottom numbers. And now I just add them. X squared and a negative x squared is 0, so those cancel. 2x plus 3x is now 5x. Now, let's go back up to the long division again. Remember, after I subtracted the 89 minus 84 and got 5, I then brought down the 1 and I started the process all over again. Well, I'm going to do the same thing. I'm going to bring down the plus 6 and I'm going to start the process all over again. Just like I said, what do I need to multiply this 4 by to get this 5? And we said a 1. I'm going to ask myself, what do I need to multiply this x by to get this 5? Well, I'd need a positive 5, so I put a plus 5. And now notice how the 5 lines up nice and neat over the plain number 6. After I do that, I now distribute the 5 to the x on the outside. So 5 times x is 5x. And then 5 times negative 3 is negative 15. Once I do that, I'm ready to subtract. Again, we draw the line and change our signs. By doing that, the 5x's cancel. And in polynomial division, the first guy always has to cancel. And then I get plus 21 at the end. Now, again, when I did this, and I got 42 right here, when I got 42, and then I subtracted, and I got 9. Remember that he's my remainder, because I was out of numbers to divide by. Well, notice in this polynomial, I'm out of numbers. 6 was the last number, so that's my remainder. Okay? Now, again, I could either put R9 up there, or I could take the 9 and put it back over whatever was on the outside. Well, similarly, I'm going to take this remainder and bring it back up here and put plus whatever that remainder is, in this case 21, over whatever was on the outside. That's x minus 3. And so, when I divide this polynomial, x squared plus 2x plus 6, divided by x minus 3, the answer is x plus 5 plus 21 over x minus 3. And that's your answer. Now, notice that in both of these, the divisor and the dividend, every x starting with x squared down to the plain number was represented, right? Well, what happens if it's not? Let's take a look at another example. Let's take a look at this example here where I've got x cubed minus 8 divided by x plus 2. Well, when I go to make my box, I know that x plus 2 goes on the outside because he's second. Ugh. X plus 2 is on the outside because he's second. On the inside, I would start with x cubed. Now, how many x squareds are present in this problem right here? 0 x squared. So I have to represent the 0 x squareds. How many plain x's are in the dividend? Those 0 x's. And then lastly, my plain number was minus 8. Notice that I want every x, starting with x cubed, down to x squared, down to plain x, down to my constant. They all have to be represented inside of here. Okay? So, now that I've done that, I start the division process. I say, what do I need to multiply this x by on the outside to get to this x on the inside? I'd need an x squared. See, without this x squared, I wouldn't have anywhere to put this x squared. Now, once I've done that, I multiply that. I distribute the x to here and the x to here. I get x cubed plus 2x squared. I then draw my line, change my signs, and I add. I get the x cubes cancel. I get negative 2x squared. I bring down the next number, plus 0x, and I repeat the process. What do I need to multiply this outside number x by to get this inside number of negative 2x squared? So what do I need to multiply him by to get him? Well, I'd need a negative 2x. I then multiply, I distribute the negative 2x to x. I get negative 2x squared. I multiply the negative 2x times positive 2, and I get minus 4x. I draw my line, change my signs. Again, the negative 2x squared and the x squared cancel like we wanted them to. 0x plus 4x is 4x. I bring down the minus 8, and I start the process again. What do I need to multiply an x by to get a positive 4x? I would need to multiply him by a 4x. So I've got a plus 4x up here. Plus a 4. I multiply it. I get 4x plus 8. I draw my line, change my signs. The 4x and the negative 4x cancel. Now the negative 8 and the negative 8, actually that creates negative 16. So that's my remainder, which I will then bring up and put plus whatever that remainder is, negative 16, over the outside, which is x plus 2. And this is the answer. And I think we're going to call it quits for the day there.